morning everyone, I am Renu Sharma, Assistant Professor EC Department. Today I am going to start with the next lecture for Unit 5, that is first lecture for Unit 5, that is related to GSM, that is Global System for Mobile Communication. So since we are talking about wireless communication, that is for mobile service, to provide the mobile services, we are using a concept or an architecture that is based on GSM, that is Global System for Mobile Telecommunication. Its full form is Global System for Mobile Communication, and another topic that we are going to discuss today is GPRS, that is General Packet Radio Service. So this is the introduction services that are provided by GSM and some of the features that I am going to cover. So first we will start with the introduction of GSM. So it is a second generation cellular system. Now second generation means with the increasing generation, like there is 1G, 2G, 3G, 4G, and right now it is 5G. That is not being practically used in the market, but it is proposed 5G. 6G is also proposed. So it is the generation means with the increasing demand of the bandwidth, with the increasing demand of the number of subscriber, the bandwidth will be increased from the spectrum, and that comprises of different generation, evolution of different generations. So this GSM is based on second generation that is used for cellular system, that is for mobile communication. Now it is world's first cellular system to specify digital modulation and network level architecture and services. Originally, it is developed to serve the pan-European cellular service, and it is promised a wide range of network services through the use of ISDN. So, with the use of this ISDN, this GSM services has been used. Now, services which are provided with this GSM is, it will follow the ISDN guidelines and are classified as either the teleservices or the data services. Now, teleservices include the standard mobile telephony and mobile originated or base originated traffic. Data services include the computer to compute communication and packet switched traffic. So this is the basic idea behind the services that are provided by the GSM system. Now GSM User Services, so these are some of the basic services that are provided by this GSM. Like first one is the telephone services, then data services, and then supplementary ISDN services. So what is telephone services means? It includes the emergency calling or fax information that you want to transmit. Then it also supports the video text or the teletext that is though not part of the GSM standard. So since it is not a part of GSM system to transmit the email messages or any kind of video data, so that is, but it is also covered under this telephone services. Next type of services that is provided by GSM is the bearer service or the data service. Now it is limited to 1, 2 and 3 layer of the OSI model. Since this OSI model, that is open source interconnection model, that is certified by ISO OSI model, it has 7 layers. 7 layers means it has physical layer, data link layer, network layer, transport, session, presentation and application. So these are the 7 layers that are being proposed by this ISO OSI model. So this GSM will work on 3 of the layers, that is 1, 2 and 3. Now it supports the packet switched protocol with data rates from 300 bits per second to 9.6 kbps. Data may be transmitted using the transparent or non-transparent mode. So that is the mode of transmission of this particular data. Now supplementary ISDN services that is supported by this GSM is digital in nature basically, and it includes call diversion, CUG or caller identification. It also supports SMS, which allows GSM subscriber and base station to transmit the alphanumeric pages of limited length, while supplementary simultaneously carrying the normal voice traffic. So this is also used to transmit the normal voice data using the supplementary ISDN services. Now, there are some of the features that are related to this GSM model. Like first feature is this SIM, that is SIM card, that is subscriber identity module. That is SIM card which is inserted in your mobile phone. Now, a memory device that stores the information such as the subscriber identification number, then the network and the countries where the subscriber is entitled to service, privacy keys, and other user specific information is also associated with the SIM card. Now, without this SIM which has been installed, all GSM mobiles are identical and non-operational. So, since we are talking about second generation, that is strictly related to provide the telephone services for the mobile phone or the cellular system, SIM card is very essential. It consists of the subscriber identification number that is unique, means in this particular area, if I am having my phone and it has a SIM card, so it has information related to that particular local area, that is considered as home location register. And if I am going to visit another cell or another place, then it will be considered as visitor location register. So, that is the concept behind this SIM card, that is very much important. And when SIM card is not installed, then all the mobile phones are identical, because there is no kind of discrimination that you can differentiate the different mobile phones with their mobile number. So, SIM card is very essential. Now, second type of feature is provided by this GSM is the on the air privacy. Now, it is virtually impossible to eavesdrop to GSM radio transmission, which means that if two people are talking to each other on mobile phone, it is not possible that the third party can listen to it. But this is a problem of crosstalk which is possible in landline phones. So, that is the major drawback of landline phones, where crosstalk may happen, means you can listen third party communication also. So, that is the drawback of landline phones, but that is not possible in mobile phones. Now, made possible by encrypting the digital bit stream sent by the GSM transmitter according to a specific cryptographic key that is known only to the subscriber carrier. So, basically, when we are using this GSM feature, or when we are talking about this GSM architecture, then there is encryption is used at the transmitter side and decryption is used at the receiver side. In case of encryption, we require a data that you want to transmit. Let's say I am talking about the digital data. So, there are 3 bits of information that I want to transmit, and that particular information will be modulo 2 added with a PN sequence, that is a pseudo random sequence that will act as a noise. Why we consider it as a noise? Because this is randomly generated, and the same PN sequence which is used at the transmitter side should be used at the receiver side, so that the decryption or the original information, let's say 101 I want to transmit, then 101 will be received at the receiver side. So, that is the main idea behind this GSM feature, or main idea behind the encryption and decryption. So, the cryptographic key, which is the PN sequence, should be same at the transmitter and receiver side. Now, next is this GSM system architecture, which is very important. Now, you can see that how a call will be initiated or how the call will be received by the mobile phone. Now, you can see over here, like this is the mobile station, this is nothing, it is your mobile phone, or mobile station can be a mobile phone or any other radio device that is moving in nature. Mobile station is not always your handset. It can be any other device which is capable of transmitting or receiving information, and it is moving in nature. So, it will be going to transmit the information through this BTS. Now, BTS is base transceiver station, which is act as a transmitter as well as a receiver. So, more than one MS is connected to single BTS, then more than one BTS is connected to single BSC. Now, BSC is base station controller, that will going to control the operation of more than one BTS. Now, more than one BSC is connected to MSC, that is mobile switching center, and more than one MSC is connected to this GMSC. At the receiver side, you can initiate a call and can initiate a call to this PSTN, public switch telephone network, ISTN or data network. So, any of the to any of the network, you can initiate a call. So this diagram is very important, apart from when we are talking about this GSM architecture. Now you can see over here that there are 4 different registers are used. Like first one is the home location register. Like if I am residing in a my communication address is fixed, or you can say that the residential area is residential home is fixed, so that is known as home location register. Now if I am going to visit some other place for a particular time duration, then it will be considered as a visitor location register. Another equipment is there, that is EIR, that is equipment identity register, that is related to the mobile phone. And next one is the authentication center, which will going to store the information related to the authentication of the mobile phone, which is specific to a mobile number, which is specific to the handset also, because in the situation where mobile phone is lost, then it is easy to track your mobile phone using this registers information, like authentication information or IMEI number plays a very important role in identifying that where your the location of your mobile phone. So this is the architecture of GSM. Now next we talk about this GSM radio subsystem. So spectrum allocation that we are going to discuss, because in second generation then third generation, the spectrum larger number of users is increasing day by day, so the demand of bandwidth is increased, so that comes under the spectrum allocation. So major approach in spectrum allocation is, first is single sideband, which divides the allocated frequency band into maximum number of channel. Then frequency reuse is there, that is cellular system, which reuse the allocated frequency in different geographical area. Then spread spectrum or frequency hopping is there. Now frequency hopping is a part of spread spectrum technology modulation, where the original data will be modulo 2 added with the PN sequence. PN sequence is a long code sequence, and there are different types of spectrum technologies are there, modulations are there, like direct sequence spread spectrum, DSS, then FHSS, that is frequency hopping. Time hopping is there, and another one is the hybrid one, where the combination of these three will also be possible. So this SS modulation is there, which will generate many code over the wide frequency band. Now this frequency utilization measurement factor is there, which is defined as maximum number of users that could be served by one channel at busy hour. So how we are going to find out the frequency utilization measurement factor X? If I am going to if I want to find out this particular factor, then for in an 24 hour, I have to select an hour or a time duration during which that particular channel is busy mostly. Means let's say from 3 to 4:30 p.m. that 1.5 hour is busy, so that will be considered as a busy hour. So in that particular duration, I have to consider how many users are going to use that particular common channel. So that will be X is equals to number of customers that will be served in that busy hour divided by the channel, so divided by the number of channels that have been used. So this is how you are going to calculate the frequency utilization measurement factor. Next one is the spectrum allocation. So it use of radio frequency bands of electromagnetic spectrum is regulated by government in most of the countries, and is process known as frequency allocation or spectrum allocation. So what is spectrum allocation? Like there are two types of allocation are there, like on demand or which is another one is fixed. Demand, on the basis of demand, like I want to transmit some information and I want to use some frequency band for particular transmission. So during that duration, I am going to ask for that particular spectrum allocation. So that will be issued by the subscriber, that will be issued not by the subscriber, by the frequency provider, that will be allocated to us so that we can transmit the information. Next type of allocation is the fixed one, where fixed set of frequencies will be allocated. That set of frequencies has to be considered that it is fixed, whether I am going to transmit that information, whether I am going to whether it is ideal or it can be ideal also. So that is a kind of wastage only. So on the demand basis, spectrum allocation is much more advantageous as compared to the fixed allocation of frequency band. Next one is the GSM frame structure. Now, the data which is been transmitted in GSM is in the form of frames. Now, frame will consist of some header information, then the required information will be there, and at the last there will be a trail bits is also there. So, GSM delays uplink TDMA frame. Now, the start of the uplink TDMA is delayed of 3 time slots. So, downlink TDMA, that is F1 megahertz, will be there. Now, this is a TDMA frame which is of duration 4.615 millisecond. Now, you can see over here that this is the fixed transmit delay of the 3 time slots are there. So, this is for T1, T2 up to T8 will be there. This is R1 to R8. Now, this will be the uplink frame that is considered as F1 plus different 4 frames will be there. So, that is related to R and T, then this will be R and T. So, you can see that this is the delay that has been provided in the uplink. Now, what is uplink? Uplink means when we are transmitting the information from base station to mobile phone, and when the information is transmitted from mobile phone to base station, then that will be downlink frequency range. So, this is the GSM which is based on either or the TDMA or FDMA. So, you can see that this is the GSM TDMA frame which consists of 8 time slots, and this GSM time slots are there, that is normal burst. Now, you can see that this is the trail bits which is of 3 bits. 57 bits are there for which is used by the user data. Now, S will be there, that is the synchronization information which is of 1 bit of data. Then training sequence will be there. Now, basically why we are transmitting the training information, that it is required for the purpose of synchronization only. Like if I am going to design a particular system and I want to train the system, then some bits are required so that it will going to work on the same frequency band if I am going to transmit another set of user data. So, that is the training sequence which is of 26 bits of data. Then again there will be a user data which is of 57 bits. Now, these number of bits are fixed. We can transmit 57 bit of data, or we can transmit lesser number of bits as compared to this 57. This is the final limit of transmitting the information. So, this is the diagram, that is the GSM TDMA FDMA frame structure. Now, this GSM frame structure is divided into different categories. Like you can see, like this is the time slot which is the same which I have discussed in the previous slide. This is trail bit. Now, tail bit is obviously it is inserted either at the starting of the frame or at the end of the frame. It is also a kind of header also which will going to head the particular time slot time frame. Now, this is the coded data. Coded data is the user data which is again of 57 bits. So, this is same as I have discussed earlier. Now, this particular slot is used in this 8 bit of frame. Now, you can see that there are 8 bits, 8 time slots are there which will going to make a single frame. Now, 26 frame will going to make a multi frame which is of 120 millisecond, and then 51 multi frames will going to make one super frame which is of 6.12 second. So, this is fixed, and this is the GSM frame structure. Now, this is the hierarchy of frames. One hyperframe is equals to 2048 super frames which is equals to 2715648 TDMA frame. Now, you can see that this much time is required to transmit this single hyperframe from transmitter to receiver. Now, you can see that this is a detailed diagram that the hierarchy of frames are there, where you can see that there is one single super frame is there, then this is signaling channel. So, whenever you are going to transmit any information, there are two types of information are there. First one is the signaling information, and other one is the voice data that you want to transmit. Voice data is carrying the actual information bits, and signaling information is going to transmit the flag that you want to transmit, or any other synchronization information, like in case of encryption or decryption, PN sequences has to be transmitted. So, that is used in this signaling channel. Now next is GSM channel, and there are different radio interfaces interface are there which will going to combine the BTS with BSC and BSC with MSC. So the radio interface is the general name of connection between the mobile station and the base transceiver station, that is BTS. It utilizes the TDMA concept with one TDMA frame per carrier frequency. Each frame consists of 8 time slots. So a single frame is made up of 8 time slots, and single time slot is having this trail bits, then synchronization bits, then coded data will be there, then training bits are there. So that is a specified kind of time slot is there, and that 8 time slots make up a single frame. The direction from BTS to MS is defined as the downlink and the opposite direction as the uplink, which means that when I want to transmit the information from BTS to mobile phone, then it will be a downlink, and when mobile phone to BTS the information is transmitted, that it will be considered as an uplink information. Then there are different channels are there, like first one is the physical channel. When an MS and a BTS communicate, they do so on a specific pair of radio frequencies. So since wireless mobile communication is a full duplex communication which require a pair of frequencies, one set of frequencies required to transmit the information from BTS to mobile phone, another set of frequencies required to transmit the information from mobile phone to BTS. So two set of frequencies are always required to communicate, to set up a communication between your mobile phone and BTS. So this is known as the physical channel. Now one RF channel will support 8 physical channels in time slots, that is 0 through 7. So which means that I have to start from 0 to 7. So that will make up a 8 time slots are there. Next one is the logical channel. The data, whether user traffic or signaling information is there, like two types of data is there. This is known as voice signal, means the actual information that you want to transmit in the form of speech signal, and this is used for the synchronization purpose. These are mapped onto physical channel by defining a number of logical channels. So this is the concept behind logical channel. A logical channel will carry information of a specific type, and a number of these channels may be combined before being mapped onto the same physical channel. So the mapping of logical channel with the physical channel is explained in this slide. Now this is you can see over here that more than one logical channel is connected, is combined in single physical channel, and this physical channel is nothing, it is the wireless channel, because we are talking about wireless communication. So that is a wireless connection that has been set up between the transmitter and receiver, and this is the message type. So different types of message types are there. These are there are 8 to 10 different channels are there which will be accompanied by this physical channel. Now next is the last topic of today's lecture is GPRS, that is General Packet Radio Service. The core network structure of GSM is enhanced for GPRS, and new elements are added to support the packet data. So two types of data are there, like circuit switched network and packet switched network. In case of circuit switched, the connection between one node to another node, like one device to another device, is fixed, and in case of packet data, the data is transferred in terms of packet in the form of packets, and it has to decide at every point that which path it has to follow, so that the time required for the transmission for the communication will be less as compared to the circuit switched network. So new elements are added in the GSM, and it supports packet data in case of GPRS. Additional hardware for GPRS that is required is gateway GPRS support node, then serving GPRS support node, and PDN, that is packet data network. Now this is the architecture of GPRS. Now you can see that this is somewhat related to GSM architecture only, where there is BTS, and to this BTS, if you remember, there is MS is connected, that is a mobile station, then more than one BTS is connected to BSC, then there will be a PCU, Then there is mobile switching center will be there. There is equipment identity register, there is SGSN, then home location register, authentication is there, global mobile switching center. So this is related to GSM only, and this is known as the GPRS core network. Now functions of GPRS elements are there, like SGSN, it enables the authentication and then tracks the location of a mobile within a network. It also ensures that the quality of service is at the required level. So whenever we are talking about communication, the quality of the call or whatever data you want to transmit, it has to maintain at a certain level. So that will be decided by this SGSN function. Next one is GSN function. So it appears as a data gateway to the public packet network and provides identity to the mobile for internet access as follows. So the network protocol used and supported by GPRS are X.25 and IP. Now if you remember this X.25 and IP, that is internet protocol, these are some of the applications that are associated with the ISO-OSI model at the 7th layer, where different applications will be function at that particular layer, like telnet is there, FTP is there, SMTP is there. So X.25 and IP is also part of that particular layer. Next is the GPRS uses packet switched data, that is an extension of GSM. So GPRS functional groups are, it will be used for the radio resource management, it will be used for logical link management, mobility management is there, like if transmitter and receiver are moving in nature, because since we are talking about mobile communication, then it will be feasible with this GPRS with the use of this packet switched network, because every node in the network is not fixed, it is moving in nature. So every time if you want to transmit the information, it has to select that which path has to follow, so that the requirement or the time required for the transmission will be less. So that is the major advantage of using GPRS. So this is all about today's lecture, where we have discussed GSM, its features and GPRS. Thank you.